Hey there, third grade. We are going to get started today on page 93. And on page 93, we're going to be working on topic 3, lesson 5. And this is just going to be practice multiplication facts. Our I can statement for today is I can use strategies and tools to represent and solve multiplication facts. All that means, strategies and tools, just a way to solve, and then represent and solve facts. To write out a fact and then solve it. And so that's what our focus is going to be. We've been talking all about arrays. We've been breaking down numbers. We've done a lot of different things, and that's what we're going to be working on and looking at as we are working on these different problems for today. So go ahead and turn with me to the next page. We're going to start on 94 as we take a look and review some of those strategies we've worked on this week. All right, so here we are on page 94. I'm going to ask you to grab your pencil with me right now as we look at our word problem. We're going to underline the important information and circle what our question is. It says, Justin and Dolores made a dragon float for a parade. They connected 9 equal sections, I'm going to underline that because that's our number, to make the dragon's body. What is the total length of the dragon's body in feet? And I'm going to go ahead and circle that. Now, I've got a question for you real fast because I only see one number here, right? So how are we going to solve this problem? What are we going to do here? Well, it says here, the dragon's body is made of equal sections, so you can multiply to find its length. All right? So they connected 9 equal sections, 1, 2, 3, 4, 5, 6, 7, 8, 9, all right, to find it. Now, I see inside of my picture here, though, each section is 3 feet long. This was not all of our information being put up here. We also needed to look at our picture and find the rest of the information, because we should have been saying, well, how are we going to find the total length of the dragon's body if all we have is 9 equal sections? We need to know how long each of those sections is, and down here is where it tells us each one is 3 feet long. Well, now that we've got that, we can write a numerical expression, which is just a number sentence, right? So we've got 9 sections, and we're going to times that by how long is each one? 3. So 9 times 3 is how we're going to write that. So here's our numerical expression based on our word problem. Well, let's go ahead and come down here to box B. All right, in box B, it says, draw a picture to find 9 times 3. Now, when we're working, sometimes we're going to ask you to do things like show us a bar diagram. Sometimes we're going to use an array to be able to break it apart into some different pieces. So if we ask for those specific ways, then I need you to make sure that you're doing that. Otherwise, you are welcome to go ahead and try it out however you would like to. So when we take a look here at box B, it says, draw a picture to find 9 times 3. Well, that's a diagram here. So 9 times 3 means 9 groups of 3. We already talked about that. So we're going to combine those groups. So here we've got 9 sections, 1, 2, 3, 4, 5, 6, 7, 8, 9. And each one of those sections, we put a 3. We want to find what is the total up here at the top. So if we added all those together, what would we end up having as our total? All right. So we could do this is you can skip count by 3s. We can just keep adding 3 and 3 and 3 and 3. But when we do that, we'll find our total answer. All right. Another way that we can do this is to use known facts to find 9 times 3. So this is one we've been working on this week too. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 going down, and each row has 3 in it. So what did we do? Well, we broke it into 2 easier problems, 4 times 3 and 5 times 3, because 4 plus 5 is going to give us that 9. All right. But these facts just become a little bit easier for us to be able to work with. So 4 times 3 is going to equal 12. 5 times 3 will equal 15. And then my last step is to add those together. 12 plus 15 equals 27. Over here, 3, 6, 9, 12, 15, 18, 21, 24, 27. We got to the same answer, but we can solve it using different strategies. All right. And it's all about what you feel most comfortable with. Do you feel more comfortable drawing a diagram? Do you feel more comfortable drawing out an array and then breaking it into easier multiplication problems? Whatever works best for you is what we want you to do, because it is up to you about what you feel comfortable, unless the question asks you to do something specific. Well, let's go ahead and turn to page 95 and check out what we've got on the next page. All right, so here we are on page 95. I'm going to go ahead and walk through a couple of these problems. Now, you can use any of the strategies we've talked about, or if you've just learned your multiplication facts and you know some of these, that's okay for you to do as well. But what we want is for you to make sure that you're picking the strategy that's going to help you best. So I'm going to model a couple of those as we go. And so if you would just practice these ones with me, and then after that, we'll get you going on your own. So for number 3, we've got 3 times 7. And so this is going to be my first one. I'm going to make some arrays real fast. And so I'm going to make 3 rows. And in each of those rows, I am going to put 7. All right, there's 1 row, 2 rows. And if you could make these with me, this is just a practice so you can remember, oh yeah, that's how we make arrays, and then break it apart into some easier numbers. So 3 rows, each row has 7 going across. I want to break these into some easier numbers. So I'm going to go ahead and cut it right here because I like 2s. 2s are easy for me to work with. 1, 2, and then I'm going to times that by 7 because there are 7 in this row. Down here, I've got 1 row, but there's still 7 going across. So I've got 1 times 7. A total of 3 rows, 2 and 1. All right, and there's 7 in every single row. Well, 1 times 7 is 7. 2 times 7 is 14. All right, so now I can add these together. So 7 plus 4 is 11. I'm going to regroup over. 1 plus 1 is 2. So 3 times 7 is 21. All right. Now for our next one, let's go ahead and do a bar diagram, all right? So we're going to make a bar diagram. So here I've got 6 times 5. So I'm going to go ahead and make my box, all right? And this time around, I want to skip count by 5s. And so I'm going to cut this in half, and then I'm going to cut each of those into 2 more. This will get me a total of 1, 2, 3, 4, 5, 6. Different spaces. Inside of each of those, I'm going to put my 5s. All right, because every single one has 5. This just helps me to keep everything organized. All right, my 6 is how many I've got going across. Inside of each one is 5. Now I can do it. 5, 10, 15, 20, 25, 30. So my total was 30. So 6 times 5 equals, you got it. It is 30. The last one I want to go together is number 6. So we've got 3 times 0. And this is one of those properties of multiplication. The 0 property of multiplication tells us anything times 0 will be 0. So 3 times 0 is just going to give me that 0. All right. So our 0 property of multiplication, I see our identity property is going to be one of the ones in 5, 7, and 8. But would you go ahead and pause your video? You can try those 3 out on your own right now, and then I will go over them together with you in just a moment. All right, I hope you had a chance to pause your video to work on 5, 7, and 8. We're going to go ahead and go over these together real quick right now. So the first one for number 5, I'm going to go ahead and just break my 9 into 2 pieces. So I know that 9 can be broken into 5 plus 4. All right, 5 plus 4. And I'm doing this because I'm reminding myself when I add those together, it's going to give me that 9. But now I'm going to just multiply each of these by 4. So 5 times 4, well, that's 20. And then 4 times 4 is a doubles fact, and that's 16. All right, so I'm taking each of those and multiplying them. Now I'm going to add them together. I'm just doing the same thing we were doing with our arrays. I'm doing the same thing that we were doing with our bar diagram. I'm just using numbers only. 0 plus 6 is 6. 2 plus 1 is 3. So 9 times 4 equals 36. For number 7, I've got the identity property. And the identity property tells me when I multiply something by 1, the other factor is what my product will be. So 1 times 7 is going to give me 7. If you want to know what that looks like, here we go. You ready? I've got 1 row, and there's 1, 2, 3, 4, 5, 6, 7. How many do I have? Well, I have 7 because there's just 1 row of them. All right. Last one that I've got is going to be number 8. And for number 8, I'm going to go ahead and break my 8 into a doubles fact, which is 4 and 4. So 4 plus 4 will give me that 8. And then I can do this a little easier. So 10 times 4 is 40. 10 times 4 is 40. When I add those together, my total is 80. So 10 times 8 equals 80. All right, when we get down to the bottom down here, you are welcome to use any strategies that you would like to that help you out. Try out our bar diagram or our arrays. Try out just using the numbers and seeing how we can break these into some easier ones. Just make sure you keep track of when we break apart a factor, we need to make sure that we add those products together. All right, that's how we can finish these up. Well, thanks so much for working with me today. I hope you guys have a great rest of the day. I will see you next time.